In this video, we're going to do the derivative of a function to a function, so f of x to the g of x, but we'll look at easier examples of this. So let's say f of x and g of x are equal to x. So you have derivative of x to the x is a question mark. So we're going to let a function y equal x to the x. And if we get the derivative of x to the x, we're really left with find dy dx. So we're going to take the natural log on both sides. So we get ln of y equal the natural log of x to the x. But the natural log property allows you to drag this to the front, which would be x ln x. We're going to take the derivative of both sides. So we're going to have the derivative of ln of y is 1 over y times the derivative of the inside, which is dy dx, equals the derivative with respect to x of x ln x. We can move the y in both sides. We get dy dx is y times the derivative with respect to x of x ln x. So we're left with dy dx equals y times the derivative of x ln x, but y is x to the x, so we can just replace y with x to the x. And the derivative of this bit of x ln x is x times ln x prime plus derivative of x is just 1 times ln x. So this will be x to the x times 1 over x. So the derivative of ln x is 1 over x plus ln x. So you're left with the derivative of y, but y is x to the x, is x to the x. X divided by x is just 1, so you're left with x to the x times 1 plus ln x. And that is the answer of the derivative of x to the x. If we look at another example, like the derivative of 2x raised to the x squared plus 1. So we have this is equal, we're going to let, basically saying let y equal 2x, x squared plus 1, and we want dy dx. We're going to take the natural log on both sides, leaving us with ln of y equals ln of 2x raised to the x squared plus 1. So we can move this to the front in parentheses. So this will be x squared plus 1 times ln of 2x. So let's take y prime on both sides, or just the prime operator on both sides. So we're left with 1 over y times dy dx equals, so we're just going to do the product rule right now of this. So the derivative of x squared plus 1 is 2x ln of 2x plus x squared plus 1 times the derivative of ln of 2x. The derivative of ln of 2x is 1 over 2x times 2. So the 2's will cancel. You're just left with 1 over x. So we're just going to plug that in. So we have dy dx equals y. So if I multiply by y on both sides, we'll get this. And y is just 2x, x squared plus 1. And the remaining terms are 2x, ln of 2x, plus x squared divided by x is just x. And then 1 over x is just 1 over x. And that is the answer to this problem.